Good day to all. We are preparing a series of lectures regarding this intermediate chemistry, fetching for international entrance and competitive exams. India is conducting JEE Advanced and JEE Mains examination that is fetching for your IIT and NIT stream for technical entrance. And medical entrance will be conducted by NEET Academy across India. That is the medical domain. In addition to this one, Telangana and Andhra Pradesh government are conducting MCET exam for BTech admissions. All the government related career opportunities, government job portals are conducting exams in the various domains where their subject specific paper will be there. In addition, a common question paper called General Studies will be provided where general science content will be given. So in the general science, what we are discussing is very much helpful. Let's go with the content, whatever chosen for the day. Let's know Nobel winning for the development of click chemistry and bioorthogonal chemistry. This is the 2022 Nobel Prize accorded kind of discovery we are going to discuss in the question number 1 as a part of this innovative chemistry. So this is a kind of innovation leading to the societal application. We will go with the Nobel winning for the development of click chemistry and bioorthogonal chemistry. So how they won, let's see. So, Royal Swedish Academy of Sciences accorded the Nobel Prize in the field of chemistry for the year 2022, right? So, every year the ceremony will be conducted on December 10th. That is the Universal Human Rights Day. And in the remembrance of Alfred Nobel, the prize will be accorded. And for the year 2022, in the field of chemistry, was given to three scientists together. Caroline Bartolozzi, he's the scientist from Stanford University, USA, and Martin Meldal. He is the professor and scientist of University of Copenhagen, Denmark, and Barry Sharpless, K. Barry Sharpless. He is the scientist of Scripps Research Lazula, USA. So these three scientists together accorded with the Nobel Prize in the field of chemistry for their development of click chemistry and bioorthogonal chemistry. These are the fields chosen for the esteemed prize called the Nobel Prize, right? So let's go with Nobel Prize of Chemistry in 2022 is about making difference, difficult to process is converted into an easier one by the process called click chemistry. Barry Sharpless and Martin Muldell have laid the foundation for the form of chemistry that is called a click chemistry, in which molecular building blocks snap together quickly and efficiently. So how the flash of click we can take by the photograph in the same manner, molecular building is also possible. Molecular building blocks can combine together by means of quick pathway so that click chemistry arised. Caroline Bartolozzi has taken click chemistry to a new dimension, started utilizing it a living organism. This is a kind of extension. Whatever concept is known to you that can be extended, that can be kind of flourished in a further manner in order to get the more benefit by the invented topic, right? Chemists have long been driven by the desire to build increasingly complicated molecules. In pharmaceutical research, this has often involved artificially recreating natural molecule with the medicinal properties. Whatever naturally occurring materials are available, those materials not in the abundant quantity, right? Same composition, we can go with the synthetic analogs. Synthetic analogs get prepared with the pharmacopoeia, efficiency and curative tendency. So that kind of research will be done in general in the pharmaceutical industry. This has led to many admirable molecular constructions, but these are generally time consuming and expensive. Okay, this is the field of most applicable and already proven one, because naturally we are using that one, and the same can be going through to the laboratory platform only, right? So in either another pathway, this year's Nobel Prize of Chemistry, which year 2022 academic year, right? So that prize chemistry deals with them over complicating the matter. We are not going to create a big molecule of complicated material. So that kind of synthesis was not the intention for the invention. Instead, working with the easy and simple molecules, simple and efficiency will be extremely larger. That is the main motto which are driving for this click chemistry. chemistry actually, right? So functional molecules can be built even by taking a straightforward route, says John Akvist, chair of the Nobel Committee for Chemistry. Simple molecules can be constructed whose potential can be unexpected. That is on the unexpected floor. So that kind of molecular synthesis was the ambition for this click chemistry, right? So here is about Barry Sharpless, who is now being awarded with the second Nobel Prize in Chemistry. For the second time, he was awarded. Sharpless is well known for Sharpless epoxidation. We already aware about that reaction, most familiar for the organic chemistry. Started in the ball rolling around the year 2000. He coined the concept of click chemistry. In the year 2000 itself, there is the establishment of new field in the chemistry called a click chemistry, which is the form of simple reliable chemistry. Very simple form of chemistry got unveiled by the scientist called Sharpless, where reactions occur quickly and unwanted byproducts will be avoided. Whatever products we require, that will be synthesized within short time, and moreover, whatever we are focusing, that product is the major one, and the discarding any other byproduct formation. Another scientist called shortly afterwards Morton Meldal. So this is the seeding idea given by the Sharpless. Later on, Morton Meldal, Barry Sharpless together they presented now the crown jewel of click chemistry, right? So the copper catalyzed azide alkyne cycloaddition. So here azide was taken. Azide is nothing but N3 molecule. Nitrogens are repeated for 3 times. Alkyne will be there. That is a triple bonded one. Whenever these two are going to bind, so that what we will get a kind of 5-membered ring will be generated. That is called a triazole. That is a common synthetic analog with the high potency, and which is catalyzed by copper metal, right? This is an elegant and efficient chemical reaction now in the widespread use. Now we generally use that reaction only for the triazole synthesis. The triazole is the effective what heterocyclic compound which is invented. The pathway is introduced by the scientist Morton Meldal and Barry Sharpless, right? Heterocyclic compounds, most of the pharmaceutical medicatives and any kind of curatives are around 80% composed by heterocyclic compounds only. Moreover, with this kind of analog like azide and alkyne, a gut combined triazole will be synthesized. That is a kind of new way of synthesis within the short span of time with a less number of chemicals. Among many other uses, it is utilized in the development of pharmaceuticals and mapping of DNA. Even genetic matter we can go for its analysis, creating materials that are more fit for purpose. So multiple applications you can find for the kind of process what they established. Multiple dimensional use we have. That's the reason why they are recorded with this prestigious prize, right? Carolyn Batozzi took chemistry to a new level, right? So themselves they established the floor for the click chemistry. The concept was introduced by the scientist called Barry Sharpless and Morton Meldal, and later on Caroline Bartozzi is the scientist who explorated in the maximum extent. He gone with the new way of new ways for the invention of new compounds by means of the same process whatever established by these two scientists, right? To map the important but elusive biomolecules in the surface of cells, glycons, she developed a click reactions that work inside living organisms, right? So it is the kind of binding tendency. Whatever technology developed by the Meldal and Sharpless, that was extended to the living organisms. How it will work on living organisms, living cells, how they respond. Her bioorthogonal reactions takes place without disturbing the normal chemistry of the cell. Already cell will be there, so they are used to introduce this bioorthogonal technology. So that concept is introduced into the living cells. Already existing environment may not be disturbed, rather they are used to impose the kind of technology over there, and they used to see the impact. So obviously they got the positive impact and worked well for the application oriented methodology, so that they are accorded with this Nobel Prize. So this is the way Nobel Prize in the chemistry for the year 2022 is given for click chemistry and bioorthogonal chemistry, right? Let's move on to the question number 2. And these are the scientists recorded. We will go with them. Carolyn Bertozzi is the scientist bioorthogonal, so living organ. She extended click chemistry towards the living organisms. And Morton Maldel, K. Barry Sharpless together established their way of new path called the click chemistry, right? So these they are the scientists mentioned over. And this is about the extensive description about click chemistry. The just now we gone with the azide that can be bonded with the alkyne. Azide is the kind of trinitrogen, and alkyne is the triple bonded carbon and carbon. So that what happens, both will be cyclized in such a manner under copper catalyzed conditions. So here triazole, a heterocyclic ring will be originated like this. So this is very short span, most efficient compound can be synthesized. This is the way a click chemistry floor was opened for new kind of research, new way of research, we can say, right? So this is the kind of molecule which can be extended to the living organisms in the further one. So this is the entire research portfolio which is accorded with the Nobel Prize in the year 2022 for these three scientists who made a work over these kind of molecules, right? So let's go with the question number 2, which is collected from Cambridge Assessment International Education. Many organic compounds contains carbon, hydrogen, oxygen only. Right. So here the question is, what compounds are having only carbon, hydrogen, and oxygen? Can you post in the comment box? There is a question. It is not to be answered over here. Now we are only going to discuss about this percentage composition is converted into the empirical formula. This is the part we are taking care about. There is a question for the comment box, that is only the compound containing carbon, hydrogen, oxygen. So these three are the elements should be present. Then what are the names of different compounds you have to mention, right? So that is the kind of question for the viewers. Okay. So this is the way: carbon composition of 48.65, hydrogen is of 8.11 percentage, oxygen is of 43.24 percentage. If these are the elemental composition of the given compound, calculate the empirical formula. Empirical formula based questions already we gone through in the earlier sessions. Again, it is the kind of practice whenever we are practicing multiple questions on the same content, so that we can get more idea about that one. Problematic session to be solved in the maximum extent, right? So empirical formula to be determined. For that purpose here, C3H6O2. So it is the compound made up of C3H6O2 called a propionic acid. If it is the propionic acid, we have to go for this calculation of empirical formula. How can we calculate that one? In order to calculate the empirical formula, first of all, the thing we need to do is, the thing we require to do is number of moles to be calculated for the individual, right? So here carbon, according to the given data, carbon is 48.65. So here 48.65 is the grams of that kind of carbon, and actual carbon atomic weight is given by, so 48.65 is the given weight by atomic weight of the carbon is 12.01. So if you get this ratio, so that you will get what, 4.01 moles of carbon, number of moles of carbon you deduced over here. And go with the hydrogen. Hydrogen is 8.11 percentage, so that 8.11 grams of hydrogen is there in the given compound. So for the given moles of this 8.11 hydrogen atomic weight, so the given weight by atomic weight of the hydrogen, that is 1.008. So if you go with 8.05 moles of hydrogen, you got it. And oxygen is also there. Oxygen is 43.24. Oxygen is given with the 43.24. You can go for 43.24 can be divided with what, oxygen atomic weight. Oxygen atomic weight is atomic weight of oxygen is given by 16. Okay, so that way you can go for the calculation of number of moles of oxygen as well. So that is given for your sake. Okay, so carbon number of moles are carbon number of moles, if you want to calculate among these two, among these two, in order to deduce the empirical formula, what you can do is, so whatever number of moles you calculated, so those number of moles can be divided with the smallest mole value. So among all the things you can go with, the smallest mole value is accorded for this carbon only, that is 4.05. 4.05 is the what number of moles of carbon which is the least value, so that actual moles of that carbon by least simplest value of mole value, if you go with this ratio, so that you will get one itself. For hydrogen, the value is 8.05. This is about moles of hydrogen. By simplest value can be taken. So that is 4.05. So that the value is 1.11. So 1.11 is equal to 2. So you can round up it as a 2. So in order to go for oxygen as well, just now we said that oxygen 43.24 is the grams weight of that oxygen can be taken. 43 by 18 can be taken, so that you can go for the calculation of number of moles. So that is around 4.05 only. That 4.05, and again the simplest value is 4.05, so that you can go for the division, and you will get oxygen number of oxygen value will be 1 only. Oxygen value will be 1 only. 1 is to 2 is to 1, so that you can write it as carbon is to hydrogen is to oxygen, CH2O. This is the way you can write for given formula, for given problem, carbon, hydrogen and oxygen, empirical formula is CH2O is the correct answer. So for question number 2, CH2O is the correct answer. You can calculate. Move on to another question. Which of the following combination will produce hydrogen gas? In order to generate the hydrogen gas, what chemical reaction is suitable among all? Here, metal with nitric acid, copper metal with nitric acid, zinc metal with sodium hydroxide, aurum. Aurum means gold with sodium nitrile in the presence of air. These many reactions are provided where hydrogen gas as the byproduct you can achieve that to be identified. Among all, zinc with sodium hydroxide will release the hydrogen gas. Option C is the correct answer. Let's solve that one. Iron upon treating with nitric acid, iron nitrate will be formed, water will be formed, nitrogen dioxide will be formed. But the hydrogen content is not released, so that you can cancel out. Copper reaction with the nitric acid, copper nitrate, nitrogen dioxide and water. Again, no hydrogen, so that you can cancel option B as well. Move on to option C. Zinc treated with sodium hydroxide, sodium zincate will be formed liberating hydrogen. There is the answer you got. Zinc plus sodium hydroxide, the product is expected to be sodium zincate, and another byproduct is hydrogen gas. This is the way sodium zincate and hydrogen gas, we are expecting this hydrogen only. This is the correct answer. Whenever Rm treated with sodium nitrile under air conditions, they said no oxygen is required. So upon these conditions, Rm able to form a complex sodium dicyanoaurate. We can say sodium dicyanoaurate is the product generated. So this is the way the product and giving sodium hydroxide as the byproduct. Can you see hydrogen over here? No. So that you can cancel out that option 4 as well. Option 4 is also cancelled out. Aurum is not giving hydrogen, copper is not giving iron, but zinc is giving hydrogen with the reaction with sodium hydroxide. So that put a tick mark for option number C. For question number 3, option C is the correct answer. Move on to question number 4. Order of the oxidation state of the phosphorus atoms in the H3PO2 phosphorus acid, H3PO4 orthophosphoric acid, H3PO3 phosphorus acid, and H4P2O6. Okay, this is the dimer compound. Among all, where oxidation state, which order we need to write? Oxidation increasing order to be mentioned. This is the way oxidation state is increasing over there. The correct representation will be provided in H3PO4, H4P2O6, H3PO3 and H3PO2. How can we get this? We have to go for calculation first. So here H3PO4. H3PO4 is called orthophosphoric acid. Here phosphorus oxidation state is mentioned as a +5 around the central phosphorus. H4P2O6 is having +4. H3PO3 is having +3. H3PO2 is having +1 only. How can we calculate? Let's see the way of calculation. If you go for H3PO4, H3PO4 hydrogen is always mentioned with +1. Everybody aware about that. Oxygen is having -2. Phosphorus to be calculated, so that put a X mark over here. How many hydrogens you can find? 3, and each hydrogen contributing +1, so that 3 multiplied with 1 plus phosphorus. How many are there? Only 1, so that put a X mark over here. Plus how many oxygens you found? 4 oxygens, each contributing -2, so that 4 multiplied with 2, so that it will be 8. Being it is a negative charge, mention negative over here, is equal to 0. So that value is the entire, being it is the neutral complex, put it to 0, is equal to 0 to be mentioned. Okay, 3 multiplied with 1 gives 3, plus X can be taken. 4 multiplied with 2 minus 8 can be taken, is equal to 0. Okay, so if -8 plus 3 is there, the difference is 5. Being larger number is accompanied with a negative sign, so that X minus 5 is equal to 0. X will become +5. This is for what? H3PO4, phosphoric acid, although phosphoric acid is having +5. Let's go with the dimer H4P2O6. 4 hydrogens are there and 2 phosphorus to be identified. Let me put 2X over here. 6 oxygens, each oxygen is having -2, so that neutral complex will give 0. So 4 plus 2x minus 12. Okay, 4 plus 2x minus 12 can be written. -12 plus 4, the difference is 8. Okay, 2x minus 8 is equal to 0. Then 2x is equal to 8. X is equal to 8 by 4, so that 8 by 2, so that you will get 4. So X is nothing but oxidation state of phosphorus is 4. When you go with H3PO3, 3 hydrogens, 3 into 1, phosphorus taken as X unknown, and 3 into each oxygen contributing -2. Okay, being it is a neutral one, is equal to 0 can be mentioned. Then 3 multiplied with 1, 3. X can be taken as such. 3 multiplied with -2, -6. 3 plus X minus 6 is equal to 0. Then X minus 3, because -6, 3 difference is 3, no? X minus 3 is equal to 0. X is equal to +3. So that H3PO3 is having +3 oxidation state around the phosphorus. Move on to another H3PO2, pyrophosphorus acid. H3PO2 when taken, 3 hydrogens are there, each contributing +1, 3 multiplied with 1. Phosphorus unknown, put X mark here. Oxygens are 2, each oxygen -2, so that you will get 3 multiplied with 1, 3. X taken as such, 2 multiplied with -2, so that -4. So the difference between the 3 and -4 is 1. 3 and -4 is 1, so that X is equal to 1. That means H3PO2 we have only oxidation state 1. This is the way all the questions got answered. Highest will be accorded for H3PO4, that is taken first, and H4P2O6 plus 4 will be there, and next H3PO3 plus 3 will be there, and H3PO2 plus 1 is there. This is the way you can give the increasing order from lower to higher. For option number C, correct answer for question number 4. Move on to question number 5. This is taken from the Telangana MSET examination conducted in the year 2023. When a radiation of 300 nanometers is shined on 5 metals are taken into the consideration, namely lithium, magnesium, argentinum, copper, and potassium. These many 5 metals are irradiated with the radiation of 300 nanometers. Number of metals that show photoelectric effect. Any metal surface, when it is irradiated or striking with the photons of light, the electrons are ejected from the surface. The phenomenon is called photoelectric effect, and this is invented by the scientist called Einstein, right? So if this is the case, 300 nanometers are focused to be irradiated on lithium, magnesium, silver, copper, potassium. Which metals are selectively showing photoelectric? All metals are not susceptible, rather only few metals we need to identify. That number of metals are showing photoelectric among all are three only. Why only three are showing? Let's see. So here there is another parameter called work function. Each metal is having their own work function value, which is mentioned in the electronic volts. This is the experimentally verified quantified values. Sodium is having 2.3, magnesium is having 3.7, copper is having 4.8, lithium value is 2.4, and another you can say 4.75 is given for tungsten. So this is about the table which used to illustrate all the metals and their work functions. If work functions are known to you, let's put on the formula. So Einstein formula is known to each and everyone, is equal to h in nu. Is equal to h nu means h is the Planck constant, nu is the frequency. But nu can be replaced with the c by lambda. Nu frequency can be replaced with the c by lambda. H stands for Planck's constant, c is the velocity of light, and lambda is the wavelength of light. Okay. If this is the case, h is Planck's constant, that is a numeral constant known to you, and c is the velocity of light, that is also known to you. If you go for the multiplication of these two, hc, the product is 1240 electron volts. 1240 electron volts is the hc value. Then lambda, which is given within the problem, that is 300 nanometers radiation. So wavelength of the light is given as 300 nanometers. Okay. hc is known to you, that is 1240. By lambda, that is 300. So that you got the energy. Energy value is 4.13 electron volts. If the energy is greater than the work function, energy is greater than work function, or energy value just now we calculated 4.13 electron volts. Okay. So always if energy is greater than work function, then only the metal which are less than this 4.13, then only they able to show the photoelectric effect. In order to exhibit photoelectric effect, work function must be less than energy. Energy is known to you, that is 4.13. Whoever having less than this numeral value 4.13, those metals are exhibiting this photoelectric effect. Okay, let's see their work function values. 4.13, less than 4.13 is the criteria. Sodium is having 2.3, it is less only. Magnesium is having 3.7, less only. Copper is having 4.8 higher value, so that you can exclude. Lithium is having 2.4, you can include. Tungsten is having 4.75, you can exclude. So in this, the eligible metals are sodium, magnesium, and lithium. Sodium, magnesium, and lithium are showing photoelectric effect because their work function values are less than the energy exhibited. So that the expected answer is 3. Only the metals lithium, magnesium, and sodium. Lithium, magnesium, and sodium are exhibiting here. So this is the way we can answer the question. 3 is the correct answer. Move on to question number 6. The correct order of ionic radii of the given species. Okay, ionic radii to be deduced. In order to calculate the ionic radii, we have to go for the periodic properties. This is a question given from periodic properties. In the periodic properties, in order to calculate, you have two dimensions. One is across the group, how they are varying, across the period, how they are changing. Both the things we need to take into the consideration, because here group value and period value both are together asked over here, right? Sodium, aluminum, magnesium, potassium, not yet all correct. Always remember, greater the cationic charge, lesser will be the size in the same period. If two metals are laying in the same period, higher the cationic charge, greater the positive charge on the metal, so that that obviously is the smaller one if both the metals are laying in the same period. That is the fundamental you need to understand. Okay, so the metals like sodium, magnesium, aluminum belongs to same period, all belongs to same period. If that is the case, the charge +3 is higher, no? So that higher is the smaller in size. So put aluminum at least. So by this only you can identify which is the smallest one. Aluminum plus 3, obviously larger charge, smaller size. So only the option having aluminum at the least size is only option number 2. After that, magnesium plus 2 you can put on, and sodium plus is there. And if you compare potassium and sodium, this is the matter of groups, top to bottom always, if both atoms are having same charge, but if you're descending from top to bottom, gradually size increases, because whenever we are descending, number of shells will be added. When shells are added, distance increases. That's the reason why anicradic got increased over there. So that obviously potassium is of next level group element in comparison to sodium. So in between these two, monopositive, being both are monopositive, but potassium is of lowest group element in comparison to lowest in the same group, lowest element in comparison to sodium. That's why as we are moving down, size will be increased. Potassium is of larger size, next level sodium, next level magnesium. Because here sodium magnesium belongs to same period, but as we are moving left to right, size gradually decreases. Okay, so here group, criteria and period both got combinedly given over here. So that given question number 6, option 2 is the correct answer. For that we have, you can go for the quantification. Potassium plus is having 152, sodium plus is having 116, magnesium plus 2 is having 86 only, aluminum plus 3 having 68. So largest is given for this potassium, and next level 116, next level magnesium, next level 68. So this is the way you can go for the descending order for the ionic radii. So in the group, the reason for increasing the size is addition of number of shells. In the period, decreasing the size because of increasing the nuclear charge, and electron remains in the same principal quantum number. And moreover, whenever positive charge increases, nucleus becomes more powerful over that valency shell, so that shrinking of ion is possible in case of cationic species. That's the reason why as the positive charge increases, the size is shrinking more. So aluminum plus 3 is the smallest. Next level is magnesium plus 2, next is sodium plus and potassium plus. This is the way question number 6, option 2 is the correct answer. We concluded the entire session. I am requesting you to like, comment and share, subscribe the channel. Thank you very much for your patient listening.